Now, if you go under, your chapter 2 module, of course, you will also see you have the homework for, the same thing, the cost estimation. And you should see an announcement for it also, just as a reminder that you have this assignment due for Friday. So I would definitely ask you guys to start working on this assignment this week. So that way, if you have any questions, you'd like me to answer anything for you, you still have time, till Friday midnight when this is due. So that way you have enough time to ask me questions about it. So you will see the questions, put them in here also. So you should be able to, do what we're doing in our handout and kind of use those examples and try and solve these guys down. So these are the, 6 questions that you guys are working on. Again, remember you have a template for this that you will be submitting your answers in. And then just details about its grading and stuff like that. So this is what the template for the homework looks like. Again, you guys will need to either make a copy of this or download it if you want to work in Excel. And then, put in your work, show me how you came up with your calculations, and then your final answer, obviously. So this is the handout that we are working on. Again, you can access this from D2L, but in chat, I will go ahead and send you the link for this. If you're not in D2L and haven't made your way to the handout. So you should be able to click on the link I sent through Zoom chat, and it will take you directly to this page. So we had worked on the first 3 examples over here. So we got done talking about, you were painting in question number 1 on both sides of the shape. So what would that cost come out to be? In number 2, we were looking at putting glass in this window. So again, basically what would be the total cost of putting the glass in? And then this one over here was an interesting example because you have a pool in the center surrounded by a concrete sidewalk. And then, of course, we were basically looking at how much sod would we need to put in the grassy area and what would the fence cost, if you put that around the grass. So this is where we had stopped as our last one. And you can see the final prices are right here under the sod cost and the fence cost. All right, guys, let's move on to example number 4. This one over here is talking about, we have the lengths of the edges of a triangular canvas. So, that's just a image of a triangle basically. So you have a triangular canvas that is approximately 120 feet by 120 feet by 170 feet. So you will see 2 of those sides have the same measurement. So what this triangle is basically showing you with these little markers is that these 2 would be the same measurement. And then, you of course have your longer side, which is across from your 90-degree angle. So this should also be familiar as a right triangle to us, right? And always when you have a right triangle, which means one of the angles is going to be 90 degrees, the side opposite to the 90-degree angle is always going to be the longest side of your triangle, okay? So those are the measurements for our triangular canvas over here. Now, basically, they are saying that if you want to waterproof the tarp, and 1 can of water proofing will treat 1,000 square feet. Well, 1, how many cans do we need? And 2, if the can will cost us $157, what would be the cost of waterproofing the tarp over here, basically? So obviously, you have the side measurement. So that's going to be 120 feet here, 120 feet here, and then the third side was 170 feet. So these are the dimensions. First of all, we need to know how many cans of waterproofing will we need. So are you finding perimeter, area, volume?
Area.
Area, very nice. Because again, if you're waterproofing it, it's kind of like paint, right? You're just painting the surface of the tarp. So we need to first start out by finding the area of the canvas, or tarp as they're calling it. So can you tell me what we need to do to find the area of a triangle, basically? And I'm gonna go ahead and put these measurements here. So we have area of the tarp, and then let's see, we are given the sides and the longest side. So we know the sides are 120 feet. The longest side is 170 feet. For the waterproofing, they're telling us it will cost us $157, and it covers an area of 1,000 square feet. Alrighty. Yeah, Terry, very nice. So though you start out with the formula for your triangle, 1/2 base times height, and then Michael, you have the answer. So let me ask you guys, in this triangle, which one would we consider to be the base and which side do we consider to be the height? So what is our base and what is our height? Terry, yeah, very nice. So again, you remember the height is always perpendicular to your base, right? It's got to make a 90-degree angle. So in a triangle of this form, basically this side will become the base of our triangle. And this side, let me see if it will let me write sideways, will become the height of our triangle. So you've got your base and height, which in this case are going to be the same measurement. So for our area, it's going to be 1/2, and I'm going to put that in parentheses. So we're doing 1/2 times base times height, which in this case happens to be the same number. So 120 times 120, and then you do the 1/2. And this will be your square feet measurement, right? Hey, Amanda. All right, so we know the area of our tarp is going to be 7,200 square feet. Now they're telling us that the 1 can of waterproofing will, basically treat or cover 1,000 square feet. So can you tell me our total number of cans that we're going to need to cover this canvas, this tarp that we have here? Okay, I'm seeing some answers coming through. Okay, so I've got 2 different answers so far. I've got 8 and 11. All right, so remember, if you are looking at an area of 7,200, and there is actually no mention of 2 sides, right? I mean, like they did in the painting of the door, what I was calling, for example, 1. So we are assuming you are only going to waterproof one side, because obviously the other side would probably be, covering whatever surface they're going to put this over. So you don't need to waterproof the inside. So you're just going to be waterproofing one side of this. So basically all you end up doing is you take your total area for the tarp and you divide it by the 1,000 square feet, because they're telling us 1 can will cover 1,000 square feet of surface. And you will see that, of course, comes out to be, because, if you have 7,000 as the area, let's say the 200 was not there. If you had 7,000, 1 can covers 1,000, then of course you would need 7. But then because we have that extra 200 feet, obviously we will still need to cover that part. And that's where the 8th can will basically come from. So you will then end up rounding up this answer. So again, you can see, guys, in this case, you have to decide, right? Do we round down? Do we round up, depending on what use we are making? And because we have extra 200 feet of canvas that needs to be waterproofed, you don't use the traditional rounding rules, you actually round up. So you have a total of 8 cans of waterproofing, liquid or whatever you want to call this. Alrighty, so the final answer, and Michael, I see you've already shared that answer with me. The final answer here is going to be, okay, so now we know how many cans of waterproofing we need. If one can will cost us $157, then what will be our total cost for waterproofing this tarp? All right, very nice. Terry, I see your answer. Michael, very good. And let me verify that. So they're telling us it's $157 for one can. So Sabrina, the area formula for a triangle is 1/2 base times height. So in this case, of course, we have our 1/2, but then your base is 120 and your height also happens to be 120. So that's basically 120, multiplied into itself and then divide by 2, which should give you the 7,200. So yeah, that's why I can see why you had more cans than what we came up with. Okay, I got it. And then let me see, Amanda, I saw your answer for the dollar amount. Did anybody else get through? Harry, Michael, I already saw yours. Okay. Okay, so let's take a look here. So basically we end up multiplying our total number of cans. And in this case, that's going to be 8 cans. So you're going to take your 8 and multiply by the 157. And that should give us a dollar amount of $1,256. So your total number of cans was 8. Oh, and that should not be a dollar amount. And our total cost was $1,256. This is just gonna be a good old number. There you go. Okay, did anybody have questions on this one? So honestly, as far as the process for solving this question goes, it's very, very similar to what we did in number 1 last time. The only difference is this one is an isosceles triangle because our 2 sides have the same measurement, and or actually an isosceles right triangle. And the shape on number 1 was a combination of a rectangle and a triangle. All right, let's clear this guy out. Now this one over here, and Terry, this is similar to the one you were talking about from homework. So this one over here, as you can see, they're telling us we have a 10-inch by 16-inch piece of cardboard. We're cutting out corners from each of the 4 sides. So of course you can see the 1.5-inch by 1.5-inch square is being cut out, and you can kind of see that in the the image that I've included in here. So the idea is you cut the corners out and then, of course, bend the sides from the dotted lines as you see them, and this will form a nice, open box, sort of like a gift box. So they're telling us we have, these dimensions for our cardboard. We cut out, we get our little box out of it. Now they're telling us the cardboard is basically 3 cents a square inch. That's the price for the cardboard. So we need to find out, what would be the price to make the box. So that's one item. Then they are saying we have beads that are $6 a bag and they hold 75 cubic inches. So that's, how much you're getting in each bag of beads. We need to know the number of bags that will be needed to obviously fill the box. And then of course, what would be the price to fill the box basically. So let's start out with talking about finding the price to make the box. What do we do here, guys? Perimeter, area, volume, all of the above? Okay, let me see. Very nice, Michael. Yeah, so we are actually still working with area to find the price of making the box, because you can see the cardboard is based on 3 cents a square inch, right? $0.03. So we basically need to first find out what is going to be the area of the cardboard. So what, okay, Amanda, you are saying area minus the height, the side of the cutouts. So what do you think the area of the cardboard should be? And like Amanda said, do we take those corner measurements out when we are trying to find the area of the box, basically? The price of making the box. So let me see what you guys think about that. What kind of measurements are you going to use? Okay, Michael, I see your value. So Michael, tell me, did you subtract the corner cutout measurements? Okay. Terry, you are talking about 10 times 16 and then subtracting 6 from it. So let me ask you this. If you were to go to a craft store, or I guess even Walmart for that matter, would Walmart give you the discount if you cut out the corner pieces from your cardboard and then charge you for only the part of the cardboard you're going to buy? No, they're going to charge you for the whole sheet, right? And that's usually how you get cardboard, is in these pre-designed, pre-shaped sheets. So in our case, basically, you're going to follow that same idea. You cannot, yeah, Sabrina, you have to use the full length and the full width. Very nice. Yeah, and you're definitely not going to be using those corner pieces, especially in this box. Now, if you have some other project you can use them on, maybe, yeah, go ahead and make use of that. So no, yeah, so you can see how they start out by telling us that we have a 10 by 16 inch piece of cardboard, right? So you are actually sticking with those original values. All right, very good. So I've got some square inches measurements coming through. So very nice, guys. Let's see, the length and the width of our cardboard was, of course, 16 inches, 10 inches. So this will, of course, be area of a rectangle, basically, right? Length times width. And this will be in square inches. Alrighty, so now that we know the length, sorry, the area of our cardboard, can you tell me how much will it cost to make the box? Now, in the price for making the box, do you leave the corner pieces out? Or do you just leave them?
You've
Yeah, I
already
mean,
paid the box.
go ahead, Terry.
I'm sorry, you've already paid for the cardboard, so it doesn't matter. You're still, like you said before. Who are you
Yeah,
gonna-
so it's a kind of the same thing, right? I mean, even though you're not using those corner pieces that were still part of, your original. So I would base my cost on the piece of the cardboard. I'm not going to worry about the cutouts. So then your price of the box will then come out to be, and let me see. Yeah, very nice, guys. So all of you have the right answer here. You are going to take your oh, sorry, didn't mean to do that. So that is our per square inch value. So basically, yes, kind of like we just did in the previous example, take your dollar amount and multiply by the area of your cardboard, which of course comes out to be $4.80 in that case. So this will be the price of our box. Now we are getting into, okay, so we've done this box, we've made this box up. So we are going to fill this up with beads. So for the beads calculation, again, what do we need to do? Perimeter, area, volume. What do you calculate for the beads part? Okay. Terry, I see your answer. Michael, I see your answer as well. So let's talk about that. What would be the volume of the box. Now for the volume, remember that's a three-dimensional, and you're almost kind of thinking about, and I think I actually did not open that link. Give me a second here. Okay, it's just to show you the formula for the volume of a rectangular solid. So our box is going to look something like this, right? Except it just does not have a top. But as far as the basic volume formula goes, this is what you are looking at. Yeah, very nice, Terry. So you are doing length times width times height. So I need you to tell me for the box, what is your length, width, and height going to be? Oh, that should say height. Yeah, Sabrina, so you can call it base. I'm calling it width, but that's basically the idea. And then the height would be the length of 1.5 inches. Yeah, and that's kind of what I'm asking you guys, so I can make sure everybody is comfortable. So Amanda, because you are cutting off those corners, you will not keep the original measurements. So let's take a look at this here, guys. Okay, Sabrina, I see your answer. But again, remember, you are chopping off corners on both sides of your length and width for the original cardboard. So, you're basically thinking about what this length is going to be, which means you are obviously going to be removing 1.5 inches from here and 1.5 inches from here. So what will this measurement come out to be? Same thing with the width of the cardboard. So this length, because you are again going to be, sorry, not that side. You will be cutting off this from the width, and you will be cutting off this from the width. So what again would become the length and the width of your box? And then Sabrina, as you said, the height would be, what corner pieces you are cutting off. Okay, so Amanda, I see your new information. Very good. So we know we started out with 16 inches as the whole length of the cardboard box, but then you took 1.5 out from this side, and you took 1.5 inches out from this. So that's a total of 3 inches. So you end up with 16 minus 3, which of course will give you 13 inches for the length of the box. So this guy will come out to be 13 inches. And then in that same way, we had a total of 10 inches. But then again, when you take the 1.5 out from the top part, the 1.5 from the bottom, same thing, excuse me, you subtract 3 inches from that, which will of course end up giving you 7 inches for the width. So the length of our box is going to be 13 inches. The width is going to be 7 inches. And then what was the height for this one, guys? Yeah, Sabrina, exactly. So you have to do it for each end of the length and the width. Yeah, your height is going to be 1.5 because again, the square you are cutting out, this distance is 1.5, this distance is 1.5. So you are going to have a height of 1.5 inches. And that will give us our volume over here. So, oops, let's see. This is going to be 13 times 7 times 1.5, which will be, of course, now in cubic inches. So very nice. Those of you who shared your answer with me, you had 136.5. So let's see, I've got Kendall, Terry, very nice. Michael, very good. All right, perfect. Okay, so you know what the volume of the box is going to be. And of course, we are assuming we're going to fill it up with beads, you know, like a nice flat surface on the top. So if the beads are costing us $6 a bag and they hold 75 cubic inches, how many bags are we going to need? And then, of course, the other question would be, how much will it cost us once we know how many bags we are going to need? So let's see, it's $6 for each bag. And 75 cubic inches. All right, so I've got 1.5. That was your height. Okay, Terry, I see that. You're taking the volume, okay, to give you how many bags and then the cost. All right, so let's take a look here. We know that we are taking 75 cubic inches for each bag, and our total is 136.5 cubic inches for the volume of the bag. So of course, you go ahead and divide those. So when you take your 136.5, which is the volume for the box, and divide it by, you know, how much capacity each bag has, which is 75, you will see it comes out to be 1.82. Now, obviously, since you're going to, yeah, exactly, Sabrina. So since you're going to come out to be at 1.82, we are going to need to round up this answer. So I'm actually just going to go ahead and put this in parentheses and use my roundup function. So it will automatically give us 2 as our total number of bags. And then, of course, you know, if each bag is going to cost you $6, that's 6 times 2, which will then end up giving you 12 as your answer. So, you know, again, you can see how this question had a combination of both area and volume. So those will be 2 completely different calculations, because with the area, you were talking about, you know, one single piece of cardboard. So we included those corner measurements in there. And, you know, of course, you end up paying for the whole sheet of cardboard. So we couldn't really subtract that even when we did the price for the box. Once you took care of that, then of course, when we were talking about the volume, now, of course, since you have created your box, those 4 corner square pieces are gone. So then as you saw, your measurement changed for the length, width, and basically the height of what your box would be. And then you based your volume calculation on that. So just be kind of mindful of that when you see a similar example like this in your homework. So did anybody have questions on this example over here, guys? Okay, so let's save this. And then this brings us to our last example here. And as you can see, we're talking about a grain silo. And grain silo is where, you know, of course, you have a cylinder at the bottom part, and then you have basically half of a sphere, which of course is what we call as a hemisphere on the top. So they are obviously asking us to find the volume of the silo, in which the cylindrical part is 50 feet tall and it has a diameter of 20 feet. And then they're telling us grain is $135 for a 42 cubic feet, you know, bag or container, whatever you want to think about it. So we want to know what the cost would be to buy the grain if we're going to fill the silo, you know, basically completely. So obviously they're asking us to find the volume. And again, just to show you, we are talking about a cylinder and a sphere. So these would be your formulas for a cylinder and for a sphere. So 4/3 pi r, and that should be a cubed on the sphere. So basically you're taking your radius to the third power, multiplied by pi, and then 4/3. For the cylinder, it's pi r square. So, basically area of a circle, because your cylinder will have a circular base, and then the height of your cylinder. So those would be the two volume formulas. So let's go ahead and transfer those over here. Yeah, Terry, go ahead.
Is 4 divided by 3 the decimal point I have down as 1.33333, and it goes on for 9 threes? Is that what we're entering when we do a calculation?
Yeah, I would say leave the repeating decimals. You don't want to round your answer too soon. So yeah, keep the decimals running. Okay, so let's see. We have our height on the cylinder as 50 feet. We have the diameter as 20 feet. Since we are dealing with radius, I would probably go ahead and convert that to, a radius measurement. So can you tell me, if the diameter is 20 feet, what will our radius be?
10.
Yeah, very nice. So basically diameter divided by 2, right? You get your radius. And both formulas, oh, didn't mean to do that. Both formulas are using the radius, so it just basically makes sense to go ahead and calculate your radius. So please go ahead and tell me what will be the volume of your cylinder, and then after that, tell me what will be the volume of our hemisphere. Okay, Michael, are you giving me for the cylinder, or are you giving me the total?
A cylinder.
Just the cylinder. Okay, thank you. All right, guys. So again, for the cylinder, if you need the formula, the cylinder is pi r square h. And you know what? I can write that here. So volume of the cylinder would be pi r square h. Volume for the hemisphere. Now the sphere by itself is 4/3 pi r cubed. And again, you can see that here. So 4/3 pi r cubed. So what will we need to modify it with, since we're doing a hemisphere? Sabrina, very good. I see your answer. Okay, so Terry, your answer is lower than your classmate. So again, guys, since you are looking at a hemisphere, okay, Kendall, I see your answer. How do we modify this formula over here? Because that's for the entire circle, right? The entire sphere. Terry, yeah, very nice. So since this is for the entire sphere and we're only looking at half of it, remember you got to divide this by 2. Yeah, very nice, Sabrina. So that would be your volume for the hemisphere. So let me verify the answer you guys gave me for the cylinder. So this one over here is going to be pi. So again, remember for pi, we are using 3.14. And you would multiply that with your radius squared. So that would be the radius raised to the second power. And then we're multiplying it by the height of our cylinder, which of course will come out to be 50 feet. And you can see this guy comes out to be, and I'm putting 1 decimal place just so you know this answer was not rounded. It is going to be 15,700 cubic feet. And let's see. So Kendall, it looks like you were slightly over by 7.96. Sabrina, Michael, those answers obviously look good. Yeah, so since this is volume, this is of course going to be in cubic feet. Okay, and I know some of you have been sharing your answer for the hemisphere, But those of you who haven't had a chance, please go ahead and show me what you came up with for your hemisphere value. So Michael, I see your answer. Sabrina, did you by any chance move a decimal point in that answer, or is that what you came up with? Terry, I see your answer. Yeah, sure. So here's the formula from the textbook. Okay, Sabrina, okay. Destiny, okay. Destiny, I don't have the answer yet, so I will check and see. Terry, you raised your hand?
Yeah, we're figuring out the cylinder, right?
So the cylinder was the 15700. So this is the volume for the cylinder.
I know, but if we're multiplying it by the 4/3, that's not a cylinder, right?
That's only for the upper half, the
Okay.
hemisphere. Yeah.
Okay. That's where my confusion is because when I did the sphere, which is what I thought we were doing last, we were doing the 4.3. Oh, okay. Never mind. I see what I did. Sorry.
Okay. All right. So some of you have shared your answer with me for the hemisphere. So let's go ahead and see what this guy will come out to be. All right. So Destiny. Okay, you forgot to divide. Okay, I see your answer. For the full volume, Michael. Okay, Amanda. I see your answer. Destiny. Okay. And then Sabrina, you've got your total. Okay, so let's go ahead and do the volume of the hemisphere, guys, so we can verify what you guys have. So I'm actually going to leave it as 4 divided by 3. Because again, like I said, we don't want to round our answer too soon. So I'll leave that as a fraction. And then we're going to multiply this with pi. Okay, Terry, I see your answer. And again, remember, guys, for pi, we are using 3.14. And then we're going to multiply this by, let's see, radius to the 3rd power. And our radius was 10 feet, so that's going to be 10. And I'm just going to use raised to the 3rd power. And then, because we are, again, we don't need the whole sphere, we're only doing half of it, you either divide by 2 or multiply by 1/2, which is what I'm doing. And I'm just going to multiply this by 1/2. And you will see, once you do that, it actually does give you 2093.33333. Repeating, and this one we can round it to 2 decimal places. I think that's fine. And this guy, of course, will come out to be cubic feet also. Okay, you did by the 2nd power. Destiny, I was just about to ask you what happened in your answer. Because 10 to the 3rd power is 1,000. 10 to the 2nd power is 100. So you can see it makes a big difference in our calculation, right? So be careful, because for the hemisphere or any sphere ball, it's always going to be r to the 3rd power. Alrighty, so very nice, guys. And you have already shared your total volume with me, but it's going to be basically taking the volume of the cylinder, adding the volume of the hemisphere to it. And as you can imagine, that comes out to be 17,793 point. And I'm going to leave this at 2 decimal places. Okay, so we know what the capacity of our grain silo is. So now they're telling us, and I'm just going to call this a bag. If your bag of grain has 42 cubic feet in it, well, how many bags are we going to need? Okay, so we have our total volume, and that's again not a dollar amount. Okay, Terry, no worries. How many bags of grain are we going to need? Because, of course, without that, we cannot find the cost of filling up the silo. Okay, Amanda, I see your answer. Let's see what the rest of you come up with. Okay, Michael, I see your answer. So since you have a volume of, 17,793.33333 repeating, it's probably going to give you a decimal answer when you try to find how many bags of grain we are going to need. So let me see what you guys are coming up for the bags, and then we can kind of discuss, do we need to round up or round down? Because I'm seeing both answers coming through on chat. Alrighty, so let's see. Each bag is 42 cubic feet of capacity. We know our volume of the silo, so take that number divided by our 42. Hold on a second. Let's see. So our grain is costing us $135, and it's got a capacity of 42 cubic feet. Okay, so for the number of bags of grain, you're going to take the volume of the silo and divide it by the volume of each bag. So yeah, this is what you guys were showing me. 400. Sabrina, how are you at 378? Terry, you as well. You were actually at 3,787. Okay, because I checked my answer on my handheld calculator also, and it does come out to be 423.6507937. It keeps going. So let's make sure we're getting the right value for our number of bags here, guys.
Are we adding the hemisphere and the cylinder together?
Yes, we are.
Okay.
Yeah. So since we are getting a decimal answer here, guys, 423.6507, whatever else. The question is, okay, Sabrina, let's see what answer you had. Yeah, I was just about to ask that, Amanda. So you had the 378.79 bags. Sabrina, so yeah, if you also did not add the volume of the cylinder with the hemisphere, then you would get a smaller capacity. That's the only answer I'm seeing in here. Let me go back up.
Okay, I got it. Okay.
Yeah, okay, Sabrina, are you talking about the 15,909? Yeah, you should be higher than that, because remember your total capacity is the 17,007. Okay, so I added them and then divided by 42. Yeah, you would be dividing by 42 because that's the capacity you're getting in each bag. So you had, and let me see, what did you have for your cylinder? So cylinder, you got 15,700. And then what did you get for your hemisphere? Yeah, see, the hemisphere should be 2,093, and you had the 209, and I wonder if that's where the difference is happening in your answer. Right, so for the cylinder, you are doing the pi r square h. So this is the volume of the cylinder, which gave you the 157, 1,000, sorry, 15,700. So that part was right. This is the one I'm talking about, is the hemisphere. So for the hemisphere, you are doing 4/3 pi r to the third, and that gives you the entire sphere, and then you divide it by 2 for the hemisphere. No, there should be another 10 in there because it's radius to the third power. And then divide by 2, yeah. So there should be one more multiplying by 10 in that answer you just gave me, and then divide by 2, and you should get the 2093.33333 repeating. So let me know once you do that, do you get the 2093 repeating 3s at the end? Well, if you look at the formula here, you will see it's radius to the third power, right? Okay, I see what you're saying. Okay, got it, got it. All right, guys. So now, okay. No worries. Yeah, just make sure you get it to r to the third power, so that way we're not, missing that again. So, Amanda, you said we have to round down, and then Michael, you were not sure if we need to round up. So can you guys give me a reasoning of what we need to do with our bags of grain? Do we round up that number or do we round down? And why? Okay, so Amanda, you are saying because you have a limited capacity, you couldn't put more than what the volume is. Michael, you are saying if we want to fill the silo, we have to round up. So here's kind of what you have to think, because this is a basically a box, right? It's just in a different shape, and it's going to have its capacity. You cannot overfill it because it's going to take what it takes. Whatever little extra you have left behind, you will not be able to get it into the silo. And these things are made of concrete, so it's not like you can squish something else in there. If it was something pliable like a box, you could probably stuff it in, tape it up, but you wouldn't be able to do that with the silo in this case. So in this case, I would say you probably want to round down, because you only have the capacity that the silo gives you, and you are not able to fill it up any more than what it will allow you. So you probably should round down. And probably just do 423 bags of grain. It's better to leave a little bit of space than try to buy too much and then not have space to store the grain. So round down. And then based on that, what will our cost come out to be, guys? And I know some of you already shared your answer with me, but what does our total cost come out to be in this case? So now that we know that we will be rounding down our number of bags, it's going to make a slight difference in what your total dollar amount comes out to be. Terry, very nice. I see your answer. Amanda, very good. Yeah, Michael, very nice. So since we are only doing 423 bags, that's going to be 423 multiplied by the price of each bag, which is 135. And as you can see, this guy will come out to be $57,105. And I'll fix this handout up so it looks a little bit more organized so you guys can try and follow that same idea as you are working through your homework assignment on this. So you will notice, well, before I talk about that, let me make sure. Did anybody have any questions on this example before I move on? Go ahead, Terry.
So I'm a little confused on where you figured out that you needed to round down. So I know you have the total volume for the cylinder.
Mm-hmm.
Was it that when you, that's where I'm confused. Do you are you multiplying what you got for your total, or what's in each bag of grain? I'm confused a little bit by that, sorry.
Okay, no worries. So basically what I did here, and let me show you how I calculated that. So basically we know this is the total capacity of our silo. And we know each bag gives us 42 cubic feet of, quantity, basically. So we took our total volume for the silo and we divided by 42, which gave us this answer of the 423.65, right? And then the reason we are rounding down is because, this is a concrete structure, right? So you cannot put more than what the capacity is in there. So if we try to do 24 bags of grain, you can only get 0.65 of that last bag in there, right? Because
Okay.
again, you will not be able to do the remaining. So the idea is, what do you do with that? And if this is the only grain storage you have, we cannot do, and that's almost 0.4 quantity of a bag, and at that dollar amount, you probably don't want to just leave it sitting outside. So it would be better to round down, because we know our silo does not have the capacity of one additional bag. So we just round down and fill it up at 423. So you're not quite at capacity, but you're not going over capacity, right? And so that's why we rounded it down to 423 and then multiply that by 135 to get your dollar amount.
Okay, now it makes sense. So it's whatever is left after you put the 423.60, 65.
Yeah,
There's
so you're
that little bit
basically
that's left.
dropping that
Okay.
0.65. Yeah.
Okay, thank you.
Yeah, you're welcome. And then, guys, like over here in this one over here with the tarp, where we were covering it with waterproofing, because we covered, we did round up our answer, because you would have, something left in your waterproofing can, but it's not like you can do the 700 or 7,000 square feet of tarp, but then leave 200 without waterproofing. So in this one, it made sense to round up. But then in the silo example, because like I said, you have a limited capacity, we cannot go over capacity, and that's why we rounded down. So it really just depends on what example you are looking at and what you're going to end up with. So yeah, Sabrina, I'm looking at your answer. So since you are rounding it down, you're not using the 0.650793 from your bag. So you're only doing 423 bags. So your dollar amount will be slightly less than the 57,192 because you're only using 423 bags. Yeah. Yeah, so just that would be your rounded answer. You're rounding it down to 423 bags, which will then give us 57,105. With the box of beads, you are actually going to have beads left over too, right? Because remember, this guy came out to be, and let me go ahead and remove. So this was our 1.82. And in this case, we are actually going to round up and get 2 bags of beads, because again, if you only got 1 bag, you wouldn't fill the entire box. So you will have beads left over. But in this case, again, it's a box made out of cardboard. So it's okay if you have beads left over. They're not going to go bad or, anything of that sort. With the grain, we cannot leave it sitting outside if it's not in the silo. So yeah, we did round up in the box and the beads also. Yeah, very good. Okay, so this is what I was pointing out, guys. You will see for the first three, I did go ahead and clean those up, from what we were doing in class, because in class, as I'm explaining this, I leave it very rough, but I will go ahead and fix this later on. So when you look at your template for the homework assignment, you will see I didn't give you, boxes or places to put your answers in like I had done with application of percentages, because I want you to do your own calculations and show me how you came up with your final dollar amount. So this is what I am looking for. I am looking for to see how did you break down your numbers? How did you come up with, was it perimeter, area, volume, what you need to do? So even though I am only giving you the final answer box, I do need to see your calculations, see where you came up with your calculations from, how you broke your numbers down and those sort of things. So just because I didn't give you all of these boxes does not mean you don't show me. I do need to see how you came up with your calculation. So you guys will have access to this completed document over here, and you're obviously welcome to follow the way we did examples in class, but please make sure you show me your work, so that way I know how you came up with your calculations. So try working on this. Like I said, you have till Friday midnight. Work on this. Let me know if you get stuck on anything you're unsure about, anything. Of course, we're meeting on Wednesday morning, Friday morning, but I'm also available by email. If you do come across something and you need help with, so please let me know whatever help you need. Okay, so it should actually be Sabrina with 423 at $135. It should come out to be 57,105. So 56,970 is you are rounding down the number of bags. So instead of the 423.65079, everything else, you're just doing 423. So when you take 423 and multiply it by 135, which is the price for each bag, right? It should give you 57,105. Okay. Alrighty, so that was the last part for the cost estimation, guys. And then, like I said, we are getting back into our textbook for, yeah. So with the bags, we are not keeping any decimals, just nice, good whole number 423. So we already looked at section 2.1 because this is where we started to make sure you guys were, had a comfortable basic knowledge of working with spreadsheets. So now we are getting into section 2.2, and we will actually be doing sections 2.2, 2.3, and 2.4 from this chapter 2. Probably not quite as detailed as what your textbook has, because again, we're doing a very basic idea of how to work with simple interest, compound interest, how to do basic loan calculations and saving calculations and that sort of thing. So this is kind of where we're headed next. I just want to make sure before I get into that, that Sabrina, you have your final answer. Did you get the 57,105? Okay, wonderful. Very nice. Okay, guys. So over here, again, we will be working with spreadsheets, and as I was telling you, we'll use some built-in functions, but I'll also show you how to work with the formulas that are given. So that way, you kind of have idea of how both of them would work out to be. So, basically the idea here is continuing to work with money, being able to do basic bookkeeping and that sort of thing. So let's start out with calculations of simple interest. So, anytime you are calculating interest, the idea is either you have borrowed money, right? Or you have money in a savings account. So you're either trying to save money or you're borrowing money, and that's where your interest is usually calculated. So basically, you would need to know what is your principal amount, and the principal amount means how much money you are borrowing or how much money you're trying to save, depending on what application it is. So the principal can also be called as the present value. So just remember, principal and present value mean the same thing. And then of course you will have your rate of interest. So the rate of interest can be a dollar amount, which normally we would actually just call it interest in that case. But when you're saying rate, interest rate, that means we're talking about a percentage. So just kind of be careful about that. Interest without the word rate means a dollar amount, but when you say interest rate or rate of interest, we are talking about the percentage, how much interest are you paying or earning, depending on if it's a loan or saving. So over here, they're basically talking about if you borrowed $100 from a friend and you agree to pay back 5% interest on that $100, then basically you will be paying the principal back, or the present value of $100 back, plus you will pay an additional 5% interest rate on it. So something as simple as you take your 5%, convert it to a decimal, multiply by the amount you borrowed. So you can see that comes out to be $5. So that means when you pay back your friend, you're going to pay them the $100 plus the $5 interest, which means you end up paying them a total of $105. And that amount is what we call as future value. So you can see the $100 is going to be your principal or present value. The 5% is going to be your interest rate, which would be a decimal number. The $5 is actually going to be your interest. So remember, that's the dollar amount. And then your future value, which sometimes we also call it as amount. So we use the letter A for that. This is where you take your principal and add the interest with it. And that comes out to be a total of 105. So that's principal plus interest. So you will see all of these formulas are given to us over here. If you multiply your principal with your rate of interest, that gives you the dollar amount for how much interest you're going to pay. So that's the initial formula. Then you take your principal or your present value and you add the interest into it, which will give you your future value or your amount. So in this case, if you're taking your original principal and adding the interest rate to it, but then you can calculate the interest by multiplying principal and rate, then this ends up becoming P plus PR, which is what they have over here. In some textbooks, you will actually see they also write it out as, I have P in both the first part and the second part. So you can actually take that guy out as your common factor. So, take this P outside and you put 1 as a placeholder. Plus this P, again, we've taken him outside. So you're just left with the R. So you can also have the formula as A equals P on the outside, 1 plus R. And that is also a formula for simple interest. So it just, different textbooks are kind of presenting it differently. But as you can see, it all leads to the same calculation. Now, in this formula that you see over here, we actually did not talk about how long we kept the money, right? Because sometimes even time can make a difference. Are you only keeping it for a few days, a few months, years, what that will be. So when you are working with time, that simple interest formula changes slightly, because now you have to calculate based on how long you borrowed the money, or for how long you kept it, like in a savings account maybe. So you will see it's pretty much the same formula, but now we also multiplied by a factor of T. So you have I equals PRT. If you still did your future value as P plus PRT, again, both of them have a P in common, so we can take that outside. So when you take this P outside, we put 1 as a placeholder. If we take P outside, you're left with R and T. So this is another form for this formula over here. So the only difference between the two is now we are including time factor. So like I said, is it in months, days, weeks, based on that? But by default, we usually leave time in terms of years. So even if you did it for 6 months, we would say, you know what, that's half a year, 0.5. So by default, we always calculate time in terms of years. Rate of interest will always be a percentage, so that becomes decimal. And then your principal, future value, all of those are dollar amounts. So just something to kind of keep in mind. So let's take a look at this example that I kind of skimmed over. There we go. Okay, so here we're saying a friend asks to borrow $300, so that will become our principal. All right, Destiny, I will see you on Wednesday. Have a good day. So you take your $300. They are saying the friend borrows $300 and agrees to pay it in 30 days with a 3% simple interest. So they want to know basically how much interest we are going to earn on this. So, think about this. You have $300 that are being borrowed. So this becomes our principal. We have a rate of interest of 3%, which will, of course, as a decimal become 0.3. And then they're telling us we are doing this for 30 days, which will be our time. But, again, we would have to convert this into years. But I'm going to leave that as it is for now. So if you were just going to calculate your interest based on your principal and your rate, you would, of course, take 300, multiply it with your 3%. And what will this dollar amount come out to be for the interest, guys? Yeah, very nice. Perfect. It will come out to be, because 3 times 3 will give you 9. And then, the zeros and the decimals kind of take care of each other, and you end up getting $9. So Michael, if you only had $100 as your deposit, you would have $3 interest, right? So multiply that by times 3 and you get $9. So yeah, very nice. You will end up with $9 in your interest, which means your future value, which is principal plus interest, will of course then come out to be 300 plus the 9. And we should come up with 309 as, what you should be paid back, and $9 for the interest. So let's take a look at your solution over here, and you can kind of see they kind of did the same math that I was just talking about. So in this case, you will notice we actually did not do anything with the 30 days because the interest was not given to us in terms of days, right? They didn't say you are paying 30%, sorry, not 30, 3% interest based on your number of days. But you will see when we get into these examples down here with time is going to make a big difference. So that's where we'll pick up next time, guys. This was just to get you guys started thinking about simple interest and, kind of where we're headed next. So we'll pick up with this. This is going to be the second half of our chapter 2 that we're going to be working on. I will have homework assignments from this in my open math, but let's not worry about that right now. You guys are working on the cost estimation homework for Friday, so please make sure you get that done. Also in my open math, your volume, area, perimeter, all 3 homework assignments are available. So work on that also, and let me know if you have any questions, okay? All right, guys, have a wonderful afternoon, and I will see you on Wednesday. Take care, everyone. Be careful. Bye, guys.
Thank you.
Yeah,
See you
Amanda,
next on
sure.
Wednesday.
Yeah. Take care. Bye-bye. Go ahead, Amanda.